Then we'll go and look at the integrator transformations. Okay, to start with, any questions on yesterday's session? Do you have any questions pending? Alright, so I think either I'm teaching pretty good or I'm not making a sense at all. So that should be the case when you don't have any questions. Alright, so hoping for the best. I think that what I'm teaching is clear to you guys. Alright, so let us go with this SQL transformation. So SQL transformation is used to do a push down operation. Okay, point number one about SQL transformation is SQL transformation is used to do a push down operation. So whatever the query that you write within the SQL transformation gets executed in the backend database, and only the results are retrieved to the BODS system. So that database depends on which you choose in the SQL transformation. Like it can be a backend database or it can be a direct source system itself. So what this SQL will do is when you select a table from your source system, source database, and you write a query statement saying that select star from this table, and these are the business valid conditions that you have to check before extracting the data. Means there are a set of filters that you need to apply. So you'll select the data store which is connected to your source system here, and you give a query statement within the SQL transformation. So what it does is instead of pulling the entire data and doing a calculation on the BODS system, it executes the entire query on the SQL system. So it will push down the operation to the source system itself. So it is not getting the data to the BODS system and doing a calculation. It does a push down to the source system itself. It does the calculation there, and it extracts only the results to the BODS system. So that is the advantage, and this is one of the transformation which is used to improve the performance of the jobs, especially when you are doing joining between multiple tables or when you have more set of conditions on extracting the data. Because as I told you, once the data gets into the BODS system, so the entire data occupies the cache memory, and again further calculations happen within the cache memory. So this might slow down the process, or the system might get stuck, or it might run unendingly. So there are many possibilities. So if you have so much of complex transformations that are that has to be done or that has to be executed, and you want to do that within the same data flow, then better go for this one, SQL transformation. The second point about SQL transformation is it acts as your source transformation. It is not an intermediate transformation which has a left-hand side connector and a right-hand side connector. It has a right-hand side connector alone, and it is a source transformation. Alright, so this is about the SQL transformation. Rishabh, are we good to go to the next? Alright, thanks. Good. So next one we'll be looking at is map operation. So why do we need something like a map operation? So if you look at the description of map operation, it says allows conversion between the operation codes. So remember this term, operation codes, update to insert on the data sets produced the desired output, to produce the desired output. So what it does is this map operation allows you to do a conversion between the operation codes from insert to update, update to delete, delete to discard. So what are the operation codes, or you call them as opcodes as well? So what are these opcodes? Opcodes are something that is pushed along with the data to the database so that this database nature will change on the target table. For example, there is a target table. So in this map operation, the target table is always a permanent table, remember that. And there is one target table, and this target table has some data already. For example, let us take a small organization like a company, ABC company, and this ABC company has some 500 employees, and there is one master tracker employee table which is updated on a regular basis till last year. Okay, so this table is updated on a regular basis every month till last year. That, okay, we have a question. Gopal, I'm not changing any screen, so can you just cross check this? Yeah, I'm not changing any screen. I'm just giving you a little introduction about this one, map operation. Alright, so you have an employee master tracker employee table, and these employee tables has to be updated on a monthly basis because your company tends to hire many people, fire many people, recruit many people, or many people's designations get changed, or they get to a different levels, and their salaries, promotions, designations, cadres, everything keep changing. So that is a complete volatile data, is not a standard data. So these changes are to be updated into the target table, but you did not do it from quite a long time. And after some time, after 6 months, you realize that you have to update this employee table. So one thing is, like, you cannot delete the existing data and load the data because you're not sure if you have the history data which is present in the table. And the second thing is you don't know how many people resigned in this 6 months period, how many people got joined, how many people changed their designations. So if you look at the data, persons who joined the organizations are like insert records. Okay, these people's data should be inserted into the target table. People who resigned should be deleted from the target table, and people whose designations are changed should be updated on the target table, right? So if you take the insert, the tables are there, and this new data has to be appended. And if you take update, the data is already present in the target table, and we are not adding new records, but we are trying to override, update those existing records. And the third set is that data is there in the target table which is no more valid, so you have to delete it. So this is a delete operation. So these are the 3 sets of operations, or you can call them as operation codes or opcodes, that are present on the data. And this map operation allows you to do a conversion between update to insert, insert to update, delete to update, update to delete. So you can play around with these conversions of the opcodes using the map operation. Okay. So now let us create a job for this one. Job underscore map underscore. And one more thing, if you execute this job in a debug mode, we'll also see how to start. Till now we are looking at executing a job in a normal mode. So we will also see how to execute the job in a debug mode, so that we'll understand what is the debug mode, and also we will see an extra indicator, opcode indicator, present on the table when we execute the job on a debug mode, which states that this is an insert, this is a delete, and this is how it gets converted. So look at those examples now. Alright, so let us create a data flow. I just created a job. I'll create a data flow. Okay, I created a data flow. Now let us take some table. Right, let us take orders. So I think I am taking the same tables and again. So just to ensure that because you are familiar with the tables and the fields, so I'm just taking the same tables. But when you are practicing, try to do it with different tables. That gives you a different, thinking that you are working on different environments. Alright, so this is the table, and on which I am trying to do a map operation. Right, so now go to the transformations tab, go to the platform and select the map operation and drag it, and I call it as normal to insert, because as per the definition it says it allows you a conversion to the table. Then the second one is insert to update. Insert to update. Okay, and let us write a query statement to select that particular data and delete that. So third one, what I want to do is like normal to delete. The next one I want to show is delete to insert. The next one is normal to update. Alright, so this is what we are trying to do. Connect. Okay. Connect. And use this query transformation here. Connect. No, not this one. So to show how this transformation works, I'm creating this job, and in this job what I'm trying to do is I'm trying to do a conversion on the map opcodes using the map operation, and then I'm trying to capture them in a table. So here the first one I'm trying to do is normal underscore insert underscore update target data store. Because in this flow what we are trying to do is convert a normal into insert and then convert insert into update, right? The second one is normal delete and insert, NDI. So normal delete and insert in the target data store. And next one is normal to update. Alright, so here we go. We just completed the framework. We have a question. Normal, Rishabh, and N stands for normal, U stands for update. Okay, we are just trying to give a random naming convention for the table. Okay, so now let me complete building this job so that you can understand what I am trying to do here. So the output of this table is always normal. So when you execute the job, the data flows out of this table, for example, through this connector is normal. So in this map operation, you have a schema in, schema out, and you have the map operation tab, under which the normal, I want to convert that to an update. Is that correct? What we are trying to do? First one is normal to insert, or insert to update, right? So first one, I want to convert normal to insert. You cannot do any changes on the input row type. You can do only changes on the output row type. And I'm trying to discard all the remaining things. Okay, I'm nullifying all these remaining three things. Okay, discard, update, insert, and delete. I'm trying to discard all these three things, and I'm just converting the normal type of data to an insert type. So if you see on the left hand side, input row type, you have normal, update, insert, and delete. These are the different types of opcodes that will be present on the data. And on the right hand side, you will have one more extra called discard, so that you can nullify that nature of the data. So now I'm converting this to insert, and now we assume that the output of this transformation is insert, and now I want to convert this insert into an update and discard all the remaining things. So when you are working with this example, try to work with a permanent table. This is a template table what we are using. Try to work with a permanent table and see if this operation is trying to update the data that is already present, it is trying to delete the data that is already present, and all these things. Okay, it will do. Okay, so first one is done. Second one, what I'll do is in a where condition where ship wire is equal to 1, and select all the remaining fields from the source, drag it to the schema out. Okay, I'm just taking a set of data which is like a ship wire is equal to 1. I'm not taking the remaining data, and here I want to convert the normal data into the delete, and I'm discarding all the remaining data because we know that output of a table is always a normal. So now this block will contain only the data which is of region ship via 1, and here I am converting normal to delete, and the second one what I will try to do is I'll convert delete to insert. So delete, I'm taking it as insert and discarding all the remaining things. Okay. And third one is a normal to an update. It's just a simple statement. Alright, so we are done with building the job. Now what is next? Save on the job. Okay, now the job is saved, validate it. Right, no errors found. So now what we will try to do is execute this job in a debug mode. So debug mode, you can either click on this, select the job, right click and start debug, or press Ctrl and F8. So you can execute that in either three ways. One is right click and start debug, or click on this, start debug, or you can go for Ctrl F8. So now I click on start debug, and this is asking me to save it. Yes. And you see a difference. This is not the normal window that we see when we do a normal execution. So it has an extra box saying that exit the debugger when the job finishes the first sample data. So you can also do a debugging on the sample data. So let us do it on the whole data. Now it will ask you a message, the job is finished, you want to debug now. To exit the debug later, select debug stop debug. You want to no, we don't want to exit the debugger because we want to see what is happening on the data. Now the job is completed. Now if you go here and see, you get the intermediate magnifying glasses across, and you will not be able to do a small change on the job design as well. You will see all these intermediate glasses, magnifying glasses, which will show the data. And one more thing, just try to change the table structure or drag anything from one place to another. You will not be able to do that. And even within the job, you cannot do any changes. Everything will be locked. Okay. So now the output of this table is normal, and now I'm trying to push an operand normal to insert. So if you see an extra indicator, opcode indicator, saying that this is an insert. If you see, you'll see an extra indicator insert on the data. Now what happens after this map operation is this normal data is converted to insert, and now the next one, let us see this insert, how it is converted to update. Okay, now you see a new here, it says that this is an updated data. And next one here, I'm selecting only this ship via region 1, and now I'm converting normal to delete. So if this is the target table, immediately after this one, this is the target table. So what it will do is, if the same data is present in the target table, it will delete those records from that particular table. So next one is I'm trying to convert delete to insert. So if you see, it is now converted to insert, and it is inserted into the next target table. And similarly, normal to update, so we are converting. So these things are the normal data sets. Okay, this is how you do a conversion between the opcodes using the map operation. And using this, you can either select a set of data that has to be deleted and convert that from normal to delete and connect it to the same target table. It will delete that data set into the target. So to exit this debugging mode, click on stop debugging, right? And you are back. You are back to the normal screen. Now you can do changes in the structure, or you can just drag them here and there. But earlier, when it is locked, will be not possible for us to do that. Okay, so this is the advantage of having a map operation, which allows us to do a conversion between the opcodes, and these opcodes are pushed, or the data sets that is generated with the opcodes are pushed down to the database level, and these things reflect the database table as per the sorry, one second. So these things reflect the target database table as per the opcode conversion that we decide. So if it is going onto the database table with a delete opcode on top of that, then that data set, if it is present in the target table, it will be deleted. If it is going with the insert opcode, these records will be inserted, and if it is going with an update opcode, these records will be updated. Because generally, if you take a normal target table, if you add records, all the newly added records, every time you execute a job, sorry. So every time you execute a job, what happens is the records get executed, and these records will be appended to the target table. But in case of a permanent table, template table, this template table gets dropped and recreated. So what it does is every time the table gets dropped and recreated at the backend database, so these new records are added as a fresh set. So what are the records that are present in this template table will be dropped, and again this table will be recreated, so fresh data set is added. But it is not the case with a permanent table. So permanent table will not be dropped and recreated. It is a permanent table, and whatever the records, how many times you execute the job, those records get appended to the target table. So to do changes onto the target table, we need these opcodes, and these opcodes push these map operation transformation, push these opcodes onto the database level and implement those changes on the database table. So this is about the map operation. It went pretty long. Took half class time. Right. Now welcome to the data integrator transformations. So these, remember one thing, platform transformations are the most important transformations that you'll be using across the globe for any migration project. So these next transformations that we are trying to see are only the supportive transformations. They are try to improve the performance or try to address the change data capture, CDCs, or try to understand how we say the history of the customer. So the same customer will be present, but his history will also be preserved on the table. So these kind of activities we'll be trying to do with the data integrated transformations. Now let us look at the first transformation. Data transfer transformation. So if you look at the description, it says allows the data flow to split its processing into two sub-data flows and push down resource-consuming operations to the database server. So there are three segments in this. The first segment is it allows a data flow to split its process into two sub-data flows. So if you are using this transformation within a data flow, that will split that data flow into two sub-data flows, one prior to this transformation and one after this transformation. We'll show it, okay? Just understand the definition. We'll show it on the system soon. So the first one you need to understand is if you use a data transfer transformation within a data flow, this single data flow is split into two sub-data flows. Okay. The second point is and push down resource consuming operation to the database server. So again, it is a push down operation. So it does a push down operation onto the database server, resource consuming operations. So what are the operations that require more resources are pushed down? For example, the data is one chunk which requires a lot of which consumes a lot of resources. So that is one operation which consumes a lot of resource. And there are some operations like, you do a lookup on the data or you do a group by on the data. All these things take a lot of system resources. So these things will be pushed down to the database server. These operations, to the, or will be pushed down, resource consuming operations will be pushed down to the database server using this data transfer transformation. Alright, so let us start creating a job for this. Job underscore DT, DT stands for data transfer, DF underscore DT. Okay, so now I have a table. Okay, I think you'll get bored looking at the same table again. Next examples I'll try to change this. Right, I have a table, and on this table I want to perform a lookup and a group by. Okay, and I want to push that into a target table. Okay, this is what I want planning to do. First I want to do a lookup on this one. Okay, and then I want to do a group by on this one, and I want to push this into the target table. So first we are doing a validation. How does a lookup perform? So lookup perform in a way that the order ID of this table, if it is present in the order ID of this second table, order details table, then it is a valid order ID. Okay, we have one more question. Why are we not taking workflow here but a data flow directly? Generally, if you want, you can take a workflow, but at this point it will not make any meaning because we are not creating more than one data flow to keep them under a workflow folder. So that is the reason why I'm taking a direct data flow. But end of the training, I'll take you through the architecture class and how you have to build the jobs and what is the structure that we need to utilize when we are building the jobs. Then definitely you will see what is the place of the workflow and why workflows are used, and what is the purpose. So when you are doing a group of data flows, you are trying to execute a group of data flows, or you are trying to build a group of data flows, and you want to call them. So it is very simple, Rishabh. So the thing is that you are going to your market and you are picking some tomatoes or you're picking some vegetables. You will not dump all the vegetables in a common bag and then again come home and try to segregate them. You'll try to put them in separate covers so that when you need all these tomatoes, you can pull that cover out. So similarly, when you are trying to do an extraction data flows, you don't want to just throw them across, because now if it is a small system, it is good. But now just for 4 to 5 days of training, we got so many data flows and you have to literally search through them. And in future, in a project, you might have 100 data flows in your repository because you might be working on 3 to 4 jobs. And you cannot dig down all those things. So that is the reason why you put them in a workflow, which will act like a cover which is holding the tomatoes. And when you need it, you can pull that cover directly out, and so that you can see what is happening within that. So that is the reason why we use a workflow, but it is not required all the time to use a workflow. All right, Rishabh, clear? All right, good. So now back to the data transfer transformation. Here we are trying to do a lookup. So how a lookup works? For example, let us assume this orders table has 10,000 records and this order detail table has 20,000 records. So what it does is it extracts all the 10,000 records into the data services cache memory, and it extracts all the 20,000 records into the data services cache memory, and it does a comparison between these 10,000 records to the 20,000 records in a way that 10,000 into 20,000 iterations on the data will happen within the PODS cache memory. So there are 2 points. One, the 10,000 records and 20,000 records are held in the cache memory, and the second thing is 10,000 into 20,000 iterations happen within the cache memory. So that is absolutely a performance hit on the system. And on top of that, we are trying to do a group by within the same data flow. So now, if you look at a data flow, once whatever you do within the data flow, gets executed at one shot in the cache memory, and once the data flow is completed, this cache memory is released and it is allocated to the next data flow. So because we are trying to use a table here at the last, so that everything that is present in the cache memory is again pushed down to the table. So on top of that, when we are doing a group by, what a group by will do, it take all these 10,000 records and try to search first record with the remaining 9,999 records, and if it identifies a similar data, it will try to bundle them into a bucket. So now if you look at these things, so on top of this lookup, what the mess that lookup makes in the cache memory, you are trying to do a group by, and this group by, it does 10,000 into 9,999 iterations on the system. So if you look at the cache memory, some 10,000 into 20,000 iterations plus 10,000 records plus 20,000 records plus 10,000 into 9,999 iterations are happening within the cache memory. So that is pretty huge. So that much of data should be handled within your system memory. So then that is practically not possible. So that also BODS can handle, but if it is like 100 million records, 1,000 million records, or at least a million records, then BODS cannot handle that. So it will execute the job, but it will run for ages together. So first let us do a lookup here. I'm calling all this and now this is the first time we are doing a functional lookup within a query transformation, so just keep this in mind. I'm commenting the order ID, and we did the same sort of lookup in the validation transformation. We tried to see if this order ID is existing in the other table or not. The similar thing that we are trying to do it now here is lookup ext. So click on the functions, select the column on which you want to perform a lookup. Click on the functions under the map tab. Lookup functions, lookup ext. So I repeat, don't get confused. Select the column on which you want to do lookup function. Go to the map tab of the query transformation. Click on functions, a lookup function, lookup ext. Click on next. Now the lookup table, the table on which we want to do a lookup, is the order details table. And now you see the input schema, the orders table, and the output, the lookup table, order details table. Now what you can do is you can select a drop down from here, or you can select the order ID from here. This is the column in the lookup table. So the order ID of the lookup table, you can change the opcodes to anything that you need, is equal to the order ID of the orders table. Then get the order ID from the lookup table, and if an order ID is not found, then the default value will be null. Okay, so this is what a lookup does. The order ID of the lookup table, this one, if it is equal to the order ID of this one, then give the order ID of the target table, and if it is not present, if it is not matching, then the output will be null. For example, I want product ID to be present in the orders table. Then how can I do that? I'll do a comparison. The order ID of the orders table, if it is equal to this one, the same comparison as we are doing here, and I will try to get the product ID as an output. So what it will do, it will create a new extra column. Okay, so I'll do this a little later. Okay, what it will do is it will get the order ID from the value, this lookup table, and if it is not found, it will throw a null. Okay, and let me do another lookup. So new output column, insert below, product ID varchar 255. Now I want to populate this particular new output column with a function. Then click on the functions, go to lookup functions, lookup ext, click on next, click on the drop down, select the table or the details, click on OK. Now give a condition saying that the order ID of the lookup table is equal to the order ID of this table, then get and you output column as product ID and you call finish. So now this product ID is populated from the order details table. Even though we are not trying to connect the order details table here, we are trying to populate this new extra column. So this lookup does a lot of stress on the system. And now if you connect this directly to the group by and open a group by and you drag all the columns that are present here into the group by tab and then to the output schema. Now this is a performance hit trap on the system. So now what you can do to improve the performance is delete this one, go to the transformations, integrator transformation, select the data transfer and drag and drop it, connect it to this one. So now as per the definition, what it does is it executes this as the first sub data flow df underscore dt underscore 1, because this is the name, df underscore dt is the name that we have provided for this data flow. So this will execute like df underscore dt underscore 1 and this will execute like df underscore dt underscore 2. Okay, so 1 and 2, it splits this one data flow into two data flows, or if you use two data transfer transformation, it splits that into three data flows. First to the first one and starting to the first one and from the first one to the second one and from there to the last target table. Right, so good. What we are trying to do with this data transfer transformation. So what are the possible things that we can do? So now you have only schema in here, only one schema, and you can either decide to do a transfer or not. So if you want to do a transfer, you can enable transfer. You can utilize this in a job, and when there is less volume of data, you can just uncheck this so that the transfer is not done and it just goes directly to the target table. Okay, you can utilize this. Even though it is present, you can hide this by unchecking this box. So checking this box, what are the options that we have? So the transfer type is automatic and this join rank is 0. So what are the different types? Transfer types are table, file and automatic. So if it is a file, the file options are activated, and if it is a table, table options are activated. So what it does is, so now the entire cache memory is occupied with this query lookup. So what it does is when this goes to this data transfer transformation, it takes the entire data that is present in the cache memory and it pushes that into any table that you specify here. Okay, remember one thing, you should not give an existing table name here. You have to give a temporary table name or a new table name here, which will be created and deleted at the time of execution. So you cannot see the table present in the database once the job is completed. It creates a table at the time of execution and it deletes the table once this flow gets out of this one. So once it goes here, the entire data is extracted and sent to the group by, and once it comes out of the group by, this table is deleted. Similarly, if it is a file, it creates a file on the desktop and it deletes the file automatically, and we will be able to see that file at the time of when the job is getting executed. We should be able to see the file when it is getting created and deleted. So let us do it on the desktop. I call this file as abcdef.txt so that it will be a unique name so we can easily identify that. So I'm trying to do a file type transfer here, and the third one is automatic. So the system itself decides either it should be a table or it should be a file. Okay, so that you leave on the system. So if it is a file, this file will get generated on my desktop and it will be deleted at the time of completion of the job. And if it is a table that I'm trying to give here, do not use an existing table name, because that table will be created and deleted at the time of execution and you will lose existing data. So what you need to do is create a new table. Just give some new table name as NEWTABLE, and just execute, and this table gets created and deleted. So now let us see how it works. So validate this one, no errors found, save this one and execute the job. So let the job get executed. I'll take you to the data flow, to the desktop and show you a refreshed screen. So now you see abcdef.txt is created and now it is deleted, which says the job is completed successfully. Alright? That is how it works. A file will be created on your desktop and it will be deleted automatically at the time of execution. And next, look at the trace of the job. So you identify that df_dt, the data flow is started. So if you see cross-check, you can cross-check on the left-hand side. df_dt is started. Then df_dt_1 is started, which is not that we have created. So it took that a separate sub-data flow, df_dt_1. Then df_dt_1 is completed, and now df_dt_2 is started, and df_dt_2 is completed. Then the data flow is completed, and then the job is completed. So now you see it is splitting the same data flow into sub-data flows. So that is what we saw in the definition. It splits its processing into two sub-data flows that push down resource-consuming operations like lookup or group by or whatever it is onto the database server, and it will try to improve the performance. So Gopal, this is one of the most important things when you are using a complex queries or more number of queries within a job or within a data flow, and you are trying to execute the job. So when you want to improve the performance of the job, check for these kind of bottlenecks on a data flow, and what you can do is you can improve the performance of that particular data flow using that one. And second one, if you are good at SQL, so I suggest you something. You can go to validations and you can see display optimized SQL. So it gives you the SQL code for that particular data flow what we are trying to do. And remember, if this display optimized SQL sorry, if this is showing two data stores here, then hopefully your the execution of that particular data flow will be a performance hit, or if it is okay, it is okay. But just in case if it is showing two schemas, so the thing is that it is going to extract the data from two different schemas and trying to create an output out of that. So we will try to maximize, try to minimize this as much possible as we can do by doing the changes on the data flow. So the less the code that is present in the display optimized SQL, the more performance you have on the job. Alright, so this is about the data transfer transformation. If you want to execute this with the table, so now let us go and select the table option, and here select the target data store. Okay, I'm just taking a new table. I'm not taking any existing table name. I just gave the name as new on this new table. Right, now you execute the job. The job gets executed and the table will be created on the database, and once the job is completed, that table is deleted from the database automatically. Alright, so this is how this data transfer transformation works. The second one is a date generation transformation, the next one. So this will be the last one that we'll be looking at in today's class. So date generation transformation produces a series of dates incremented that you specify. Okay, it will create a new output column. For example, you have a table and you don't have a column, date column, but you need the date column, so utilize this one. But frankly saying, I haven't used this anywhere in all my experience, but this is what is available with your data transfer transformations. So let us know how to utilize this. So df_dg, DG stands for date generation. Now I have a table. Okay, let us drag this. This is a source transformation. This is not an intermediate transformation. This is a source transformation, and so it is capable of creating okay, a table directly even without the help of any other source tables. So you can create a table and populate that with all the different values. So now add a query transformation in between and connect this query transformation to the table date generation. So if you open the date generation transformation, all you can see is one schema out which has only one column, and at the bottom you see a date generation tab, and in the date generation tab you see a start date, end date, incremental mode, and the join rank. So this is again a very simple transformation. For example, you want to do some calculations based on the January month of 2013. So you select the start date as 1st Jan 2013 and end date as 31st Jan 2013. Okay, and you can choose the incremental as daily, monthly, weekly. Okay, you can choose on that. So I keep daily, and what I do is go to the query transformation, drag and drop this as an output, and execute the job, and I create a table with 30 days date. Okay, so from Jan 1st to 30th I get dates populated in this one. Okay, so this is from Jan 1st to 31st, and you can utilize this column in some other table by just using this row generation. Add the table, new output column. Now let us see what are the different functions that we can utilize here. So if I go to the functions, go to the date functions, you can see all this one like month of, quarter of, system day, system time, week in the month, week in the year, year, day in the month, day in the week, day in the year. So you can calculate all these things. Okay, so now let us create some of the new output columns and calculate the values here. So year, the next one is month, day in month, day in year. So I'm just taking these examples now. So what you need to do is today's date, okay, and I'm trying to create these few examples, but there are many date functions. So try to utilize all these functions when you are practicing on your system. So today's date is system date. So what are the date that is present in my system? It will get the value there, that is system date. Day in month, day underscore in underscore month. So these are the different functions that you can do. Which day of the week, which day in the year, which day in the month. So I'm taking the day in the month. The next one is year of this particular date. You get this one. Then month of this particular thing, which month of this date is that, and day in the year, day underscore in underscore year. Okay, day in month, I think I should drag this one and show it here. Oh, come on. That's the date. There is no need to give this column, but day in month, to calculate which day in month of this is this particular date. year of, which year is this particular date is having, month of, which month this particular date is having, and the day in the year. We need all those things. So now validate this one, no errors found, and execute this job. Alright, the job is completed successfully. Now let us go and look at the data. Now today's date is 31st Jan 2013 as per Indian calendar. That is 31st Jan 2013, and day in the month is, this one is the first day, this is the second day, third day, fourth day, and so on. And this year is 2013, and the month is 1, and the day in the year is 1, and this one is 29, 28, and so on. Okay, so this is 29, so this is the 29th day of the month. So if you get to choose the date in the Feb, right? So let us take the end date as Feb 8th, and now execute the same job and look at the change in the values. So it will give you more than, the date will be first, second, and so on, and you can see. Okay, so and you see this is the 34th day in the year. Let's use the month ID as 2 because this is a Feb month and the year is this, and day in the month, again it starts from 1 when it comes to the Feb. So this is how you create a new extra columns with the date values, and you populate them with the built-in functions and utilize them within your job whenever it is required. But for me, I haven't got a chance to utilize them in all my experience, so probably you might get in the future, probably when you are trying to create a new output column with the date value. So that's it for today's class, and we'll catch up tomorrow, and we will look at the next things like effective date and history hierarchy flattening, then history preserving, key generation, table comparison. These three combined in one job we will see: pivot and reverse pivot, XML pipeline, and map CDC. So once we are done with this, right? So once we are done with this, we will be completing the integrator transformations, and in the mesh and the data quality, as I told you, rest of the things will come with the price tag, so we cannot utilize them for free. We can use only the mesh transformation, and we'll look at the base mesh transformation, how to utilize this, and that gives you a clear picture like how to utilize all the quality transformations, because the GUI of all the quality transformations is one and the same. Okay, so then we'll be completing all the transformations. So probably in a day or two, in next 2 classes or next 3 classes, we'll be able to complete the complete transformation set. Then after that, we'll go to the real-time jobs, then we'll look at the data insight and all this stuff. Okay, right. So any questions, please email me, and thanks for your time. Have a good day and good night.